Hi guys, welcome to Coding Ambitions. In this video we will learn about how we can use Decompose with iOS app lifecycle. So before that I will be talking about the one of the previous video in which I have used this Decompose. So you can check out that navigation in Compose Multiplatform using Decompose. So you can check out that video before this. And this is the project that we created in that video. So if we run it, I will show you. So in the Decompose, so we can implement lifecycle.callback. So this is the lifecycle callback implementation. Here we can create all the lifecycle related methods similar to Android. So if we see now, as we have attached this lifecycle registry directly here, the component context, and created the root component and passed that here, right? So if we see here and try to run it, so it does not print any logs there. So if you see, right, so let's print it and rerun it. It will not print any logs there. You can see app is running now. No on create is called there, and similarly no on pause, no on destroy, these will be called if we use it like this way directly from Compose. So I will show you. So if you see, app went to the background and then coming to the foreground, it should display the on pause and on stop as well, but they didn't happen, right? So, and also if I terminate it, so if I just destroy it, no on destroy is called here, you can see. So how we can do that, how we can use the Decompose with the app lifecycle for the Android, for the iOS app, right? So let's continue with that. For that, first of all, we need to open this iOS app for this app inside the Xcode, right? So here you will be doing minor changes. So in these two files, so what we will be doing is here, first of all, let's create a root holder class. So that class will be holding the lifecycle related stuff. Root holder, and then here we can make it observable object, right? And then let's define lifecycle. First of all, so we need to import what is the module name of the app. So if we see that, if you see, yeah, for the iOS, here we are exporting it, base name is Compose app. So we need to import this Compose app here, right? Even before that, so if we want to use Decompose in iOS side, so first of all, first step will be like we need to import those dependencies from here, right? So for that, what we can do is we can call export, and then we can use these dependencies for the Decompose which we have added. So we can export them, because once we will be exporting them, only then we will be able to use them inside the iOS code, right? So let's do that. And one more thing we required for these same two dependencies, even actually we can copy the common main ones or Android mains. So we need to add these dependencies. We need to specify these as APIs. That is mentioned in the documentation so that they will be available for exporting, right? In the iOS main, right? Let's specify them as API, right? So that they will become exportable, right? So these two steps, first of all, we need. Now let's sync it, and then we will be proceeding to the here. So and we need to import Compose app because that is the base name for the iOS binaries, right? If you see, yeah, this one. So let's import this one, and now let's try to create lifecycle. We need to use here lifecycle registry. It's not yet available, so let's try to build once, and let's comment this first. During build, it will be making the build of the project so that the dependencies will be available there. Now let's try it. Lifecycle callbacks, lifecycle registry, that is still not available. So let's check it again. We have exported them. Actually, I missed one thing. So we need to export decompose and SMT lifecycle. So we can add this is also the dependency developed by the same author who have developed this decompose. So SMT lifecycle GitHub. So we need to add SMT lifecycle. We can find it here. Now let's check its path, how we can integrate it. Yeah, so we need to add this one. And what is its latest version? Its latest version is 1.3.0, right? Okay, so let's add that here. Okay, and now let's add 1.3.0, right? So similarly we can make it exportable, specifying the API dependency. Let's sync it. Yeah, now I think it should work. Hopefully it will work. So let's just build it so that dependencies will be available there. Something is wrong. Let's check it. Following dependencies exported in the debug framework binary are not specified as API dependencies, but we have specified them here. Oops, we have, my bad, we changed it at wrong place. We need to change it at here. Okay, and this one, let's put it back inside the Android main where we changed that by mistake. Okay, so if you will be confused, let me repeat these two steps. What we need to do: so first of all, we need to export these two dependencies, the decompose, right, and then the SNT lifecycle, right. This is the required, SNT lifecycle is required by decompose for the lifecycle handling, right. So and then second thing is we need to make both of them API, declare both of them as API here in the iOS main dependencies so that they will be exportable, right. Let's sync it and try to run it. Let's build it. Let's run it so that it will be generating the binaries. It will not build until we comment this. So let's build it again. So after the build, it exports the dependencies and creates the binaries there, but before that they are not available in the iOS side. Yeah, it's showing. I was spelling mistake was there, so it's showing now. First of all, we need to create an object of, define an object of lifecycle registry, right. So this root holder will be holding everything related to the lifecycle. And secondly, let's create a root component here. So what change will be required for that? what we are going to do is we are going to attach the iOS app lifecycle with Decompose. So this part, this stuff will be doing from the iOS side, so that it will be attached to the iOS app lifecycle, right? So this is the root component, and let's define its kind of constructor here using the init, and then let's lifecycle registry get it dot this way it is exportable in from this name, so we can use it in the other side from this name. And then let's lifecycle dot subscribe. So now if you see here, we have subscribe this class, right? So the same thing we can use there. Later we will remove this code, so we can add that here, right? And as we have view model as well, so let's define that view model here, and then let's initialize the default root component. So inside the component, so even we can copy paste this if required. So we will make little bit changes there, right? So default component context, and inside default component context, so we are passing lifecycle, right? So this lifecycle registry, we are passing it here, and then in the second parameter, so here we need to specify them as label, right? Yeah, fine. So this way we have defined the root component. It's similar to the way we have implemented here, but now we will be doing this stuff from iOS side, and we will be binding them to the iOS app lifecycle as well in a bit. So now let's create lifecycle registry ext, yeah, extension.get. It will be creating the lifecycle registry. So here we can define the lifecycle registry lifecycle. Yeah, it can directly accepting that parameter without label. So yeah, so now it will be creating those lifecycle stuff here, right? So and inside the day init, what we can do is lifecycle dot destroy as well. Here we are creating this extension, here we are destroying it, so we can pass the same here, right? So now root view holder is ready, and now we need to create a class. So app delegate, if you know about that, is similar to the application class in the Android app. So now we will be creating a app delegate here, and it is extending the NS subject and UI app application delegate, right? It's the application level class. You can just think of it like we have application class in Android, right? So now let's create root holder here, right? So now this way we are creating the object of root holder inside this application class. So it will be bound to the application now, right? So here it will be creating the object whenever application is starting, right? It will be bound to the application lifecycle now, right? And now what we need to do is now we need to use this @UI application delegate adapter app delegate dot self we need to create the object of that, right? So now this app delegate, what we can do is, so in this content view, basically what is going to happen is, now we need to pass the root component here, and from here, this from this content view to this compose view here, and from here to this view controller, that is this class, right? So now let's accept one parameter here, root component, that is root component, and let's pass just this one here, right? So instead of this code, now we'll be passing this one, and here let's create one variable of root component, and similarly let's create it here as well, right? So now let's pass it here, and from here let's pass it here. So now this content view is used here, so we need to pass or even we can create the root holder variable here, because we need to use it at many places. So let's create this variable here and have delegate dot root holder and directly use that here, right? So now what we need to do is we need to use some callbacks here on receive publisher, right? So why do we need that? So for subscribing with the app lifecycle, we need to use these callbacks. So here we can use notification center dot it was what it was, notification center dot default dot publisher. It will publish UI application dot events. These events, it become active, enter background, receive map warning, did finish launching. So they are related to the app lifecycle. So here we will be using the become active, right? And yeah, we don't need that parameter. And so here, yeah, good. So here we can print here as well. So if you see, what we can print is Swift on create did become active. No, it's for resume. Did become active, Swift on resume. And here we need to attach them as well with the lifecycle registry extension kt dot resume. Yeah, resume, and receiver will be the from where we have the lifecycle inside this. Yeah, this one, right? And now similar to this, yeah, it requires a label here. So now we can just copy paste them, and then what we can do is we can keep them adding here, and now it will be the will resign active. Yeah, the will resign active, this will be the similar to the on pause. So here we can trigger its pause method. Yeah, the pause method, right? And now it will be the on stop, maybe enter. Yeah, enter background, it was for on stop, and here we need to trigger the lifecycle registry callback. So this process will be doing the binding here, and now the terminate, this is for destroy, right? And here we are calling the destroy. Okay, and also we can unsubscribe here as well. So whenever app is destroyed, we can unsubscribe root holder dot lifecycle dot unsubscribe, because after that we don't need to get subscribed to the lifecycle. So which class it was? Let's check it. Yeah, this one. Okay, so some issue is there. Let's check it. Okay, yeah, this bracket was extra. We don't need this. Yeah. What it's showing now here is okay. Requires the argument callbacks. Okay, now it's done. Yeah, it's done. So now, yeah, now let's try to run it. We can run it from here as well, or from here as well, anywhere, from anywhere. So similarly we can check logs here as well in the Xcode. The logs which we are checking here, same things we can check there as well. So let's check it. If you see, on create is triggered. Yeah, app is running. So let's check it. Yeah, so first of all, it is, if you see here, this is the, just you can mention it here. Right. So yeah, it is app is on, because after on create on resume is called. So we can, if we are using the on resume here, so we can, this resume method we can use here on pose and on stop. Okay, now let's run it again and check. So if you see, now they are in the sync. So whenever Swift app is on resume called, at the same time we have this lifecycle callback. Same method from this lifecycle callback is called. If you see, and if I just press home button, if you see, it will be calling the on pause. Yeah, on pause, on stop. Right, first on pause, then on stop. Right, and now again, if I do make it active, it should call on resume, right? And one thing meaning that is like, if we destroy it, it should call the on destroy. So actually for the destroy, whenever this root holder will be destroyed, we have triggered that callback here itself, right? So we don't need to add that here. Right, now let's see. Okay, so similarly on create is being called here. If you look, print logs there, so on call will be called here whenever app is created, right? So this is automatically attached. Destroy is also attached here, but we need to attach these: resume, on pause, on stop. So these methods we have attached, but on create and destroy were already attached here, right? It's destroying automatically here though, but still we need to, whenever Swift app is destroying, we need to tell our life cycle that now it need to destroy, right? So guys, this is all about the how we can attach the iOS app lifecycle using Decompose in Compose Multiplatform app, right? So in the previous, if you see this code, by this code, So it is not attaching any, it is just using the simple lifecycle registry implementation, but not attaching this implementation with the iOS app lifecycle, right? So that is not, this is not the correct way. This is the correct way. We can attach, and we can, if we want to do any kind of stuff here, so we can do that stuff here. And also, even if we want to use this class inside here as well, we can implement that class here as well and then use that. But I have implemented it from the Kotlin side, Compose side. So that's all about, guys, how we can attach the iOS app lifecycle with Decompose in Compose Multiplatform app, right? So I hope you guys have liked the video, you have understood the concept, how we have attached it. So we have created a, so what we need to do for that, this stuff, we need to move this stuff to the iOS app and then pass that root component here. And there what we need to do is, we can create one root holder for holding all the lifecycle layer stuff, and then start that inside the app delegate. So it will be attached to the application lifecycle right here, and then attaching this particular method right with the lifecycle methods of the decompose, right? So Swift, or we can say iOS app lifecycle methods, are getting attached to the decompose lifecycle here, right here. So that's all about it. I hope you have liked the video. If you enjoy like the video, you can share it. Please like, comment on it, and if you are new to my YouTube channel, please subscribe it. So these things motivate me to create more videos like this. So this is all about. I will see you in the upcoming video. Till then, bye bye, take care, have a great time, keep coding.